Hello students, this is Unit 2, Lesson 6 Practice Problems. We're starting on page 182 and we'll just jump right in. Everything on this one is going to be about equivalent equations, and then we're going to do a little bit of review on your statistics from Unit 1. So let's go through this. It says number 1, which equation is equivalent to the equation 6x plus 9 equals 12? Alright, so we can kind of look through here. Looks like it's all about kind of the same format. So let's just see if we can do the same thing. Can I make this thing look like that somehow? Well, let's see. If we take a 6x plus 9 equals 12, you'll notice something unique about this. And what do we have here? Well, we have a 6, a 9, and a 12, and each one of those are a multiple of 3. So I can go and factor a 3 out of every one of those. And I can factor both sides, right? 3 goes into 6x how many times? Not once. It goes in there 2x times. Plus goes down to a plus. How many times does 3 go into 9? Well, 3 times. How many times does 3 go into 12? 4 times. All right? So again, I did the same thing to both sides. I factored out 3 out of both sides. Now I need to divide both sides by 3. So I have a 2x plus 3 equals 4. So this and this are equivalent statements. Okay? So we'll see if this lies in our answer. Alright? Nope. Yes. Nope. Nope. Well, some of these might be another version of these things. So you have to be kind of careful. I know that one works. Right? This is, but we state this, which equation is equivalent. It doesn't say like there's more than one answer. So now that I found the one that I liked, we'll just go through. Is there any way for this to go back to this? Let's see. Well, what happened here on this bottom one? Looks like they just swapped 12 and 9. You can't just swap 12 and 9. Okay. You might be able to put a negative 12 down here and a negative 9 on the other, but nope. Not allowed to do that. You can't just swap numbers when you feel like it. Let's look at this one. What did they do? Well, it looks like they took a 2 out of the 6x to get 3x, and took a 2 out of the 6 to get 3, but they didn't take a 2 out of the 9. Wrong. Can't do that. You got to do the same thing to both sides and all the terms involved. So that's out. X plus 9 equals 6. So they left the 9 alone, and it looks like they took a 6 off of here, and then they took 2 off, or divided by 2 to get there, so that's completely screwed up. So, no. The only one good answer is B. Number 2, select all the equations. There might be more than one answer. Select all the equations that have the same solution as 3x minus 12 equals 24. So let's go and look through this. So 3x minus 12 equals 24. So we're going to look at this real quick. And it looks like everything is a multiple of 3. So let's go and just factor a 3 out. See if we can get a equivalent statement out of this. 3 goes into 3x, x times. Minus goes to a minus. 3 goes into 12, 4 times. 3 goes into 24, 8 times. I divide both sides by that common factor of 3. And what do I get? X minus 4 equals 8. Okay, so there's an equivalent statement of what we've got. Let's see if anything lines up here. Well, let's see. So I got, I got X minus 4 equals 8 right there, so I know that D works. All right. Let's look at this first one to see if I can get from here to here. Well, if you look at this, I got a 15 versus a 3, so I'd have to multiply that by 5. And 12 times 5 is 60. And 24 times 5 is 120. And there is a subtraction here, so there is a subtraction here. So I could take that 3x minus 12 equals 24. And I can multiply both sides by 5. 5 times 3 is 15x. Minus 5 times 12, which is a 60, equals, and multiply this side by 5. 5 times 24 is 120. So, yeah. And if you want to like a little note here, multiply by 5. Yep, that's what they did. This one, 3x equals 12. No. Let's look at that one real quick. Why is that one screwed up? You start with 3x minus 12 equals 24. All right, so what they did here is they just have all the x's on one side and the numbers on the other. That's all they did. All right, so they moved this 12. Well, how do you move the 12? Well, you have to undo what's being done to it. You're subtracting the 12, so you need to add 12 to both sides. So it goes away over here, and then 12 plus 24 is 36. So 3x equals 36. It doesn't equal 12. It should equal 36. So that one is wrong. Oops. 3x equals 36. That one we just went through and made. We just went and solved. So, oh, good. In doing that one, I figured out that that one's okay. So we'll circle that one. We already did this one in our first attempt. And then this one we got first thing too. All right. Let's look and see if this one's any different. 12x minus 12 equals 24. Well, the 24s are the same. The minus 12s are the same, but you went from 3 to 12x. You can't just like take one term and make it bigger and hope for the best. So, no, that one's completely jacked up. No, you cannot do that. Number 3. Jada has a coin jar containing N nickels and D dimes worth a total of $3.65. The equation of 0.5 times N plus 0.1 times D is $3.65. Makes sense? That's 5 cents is 0.05. That's the value of a nickel in terms of dollars. 0.1, that's the value of a dime in terms of dollars. So in this, here should be $3.68. Is one way to represent the solution. Which equation is equivalent to this one? Okay. Can I get from here to here? Well, what did they do? I went from 3.65 to 365. So it looks like they multiplied that by 100. Well, if I multiply this side by 100, then 0.05 becomes a 5. And that times 100 becomes 10. Boing. That's not there. All right? No. Needs to be 10D. That's wrong. Nope. Alright, so let's see what they did here. Here they multiplied one side by 100, and then they somehow went from, they multiplied this by like 10, and then they multiplied this by 10, so they multiplied the left-hand side by 10, and the right by 100. No, you have to do the same thing to both. You can't just do stupid things to one side and then even dumber things to the other side. No. Alright, let's look at this one. Alright, so they went from 3.65 to 365, so it sounds like they multiplied it by 10, or excuse me, by 100. So 100 times 0.1 is 10D. Oh, good. And then 100 times 0.05 is 5. So if you look at these two right here, they're really similar. It's just that this one has the correct number in front of the D. So that's why Charlie's correct. And then you look at this. They didn't change. They changed around the dimes and the nickels and multiplied this side by 100. So this thing's completely jacked up. Completely screwed up. Yeah, I don't know what they were thinking there. So, no. Just Charlie is the answer on that one. Let's look at number 4. Select all equations that have the same solution as 2x minus 5 equals 15. So 2x minus 5 equals 15. That's our goal. All right. So 2x equals 10. Well, if you look at this thing, we can actually solve this. Let's go and solve it. I want to solve for the x. What do I need to do? Well, I'm subtracting 5, so we're going to do the same thing to both sides. We're going to add 5. 5's cancel. I get a 2x. That's all I got on the left. 15 plus 5 is 20. Now it's 2x's or 10. 2x's are 20, so I'm going to divide both sides by a 2. That's the unknown. That's the coefficient of the unknown. So you divide by the coefficient of the unknown. And then 20 divided by 2 is 10, so x equals 10. Okay, so let's go through here. 2 times x is 10. Well, if I divide both sides by that's the unknown, we divide both sides by the coefficient of the unknown. Here, that x turns out to be a 5. So that's out. That's not an equivalent statement because it didn't bring it to the same solution. 2x equals 20. Well, yeah, we just got that one. We just had that. So that's okay. 2 times x minus 5. Let's see what that looks like. So if we just go through and do our distribution trick, 2 times x is 2x. 2 times 5 is a 10, and I still got to subtract from before, equals 15. Well, here it's 2x minus 10 is 15. Here 2x minus 5 is 15. So no, that's completely screwed up. This one and this one are very similar. So how do you get from here to here? Well, we took our 2x equals 20, and I just simply subtracted 20 from both sides. The 20s go away, so what do you have on this side? Well, obviously 0. And then what do you have on this side? Well, you have 2x's minus the 20. Alright? And that's what they got there, 2x minus 20. So yeah, that's the equivalent statement. I like that. 4x minus 10 is 30. How'd they get there? Well, let's see. You got a 15 to a 30, a 5 to a 10, a 2 to a 4. It looks like they multiply everything by 2. If they multiply everything by 2 on this side, and 2 by 2 on this side, you'll get that exact answer right there. So I like Echo. Echo works. And I don't know what this thing is. 15 equals 5 minus 2x. Well, they got a 15 like right here. They got a 5. It's a minus 5 here. Here it's a plus 5. And here's a positive 2x. That's a minus 2x. So they did some screwy multiply by a negative 1 on one side, not the other. So this is completely jacked up. So Bravo, Delta, and Echo are the only appropriate answers on that one. Alright? And now some review questions, which I'm sure you all look forward to. The number of hours spent on an aeroplane on a single flight is recorded on a dot plot. The mean is 5 hours. So right there. That's the mean. Notice this little guy. Whee! All the way out here. 26 hours on an airline. Yikes. I wouldn't want to do that. Alright. Let's see. So the mean's 5 hours. The standard deviation is 5.82. That's a huge standard deviation. Standard deviation takes you, when you're starting at 5 and you go to the left 5.82 and you're off here in 0, you're beyond the left. So that's how big that standard deviation is. The median is 4. Let's see. The median is 4 hours, and the IQR is 3 hours. Okay, so here's the median at 4. That's the middle. You got half on this side and half. The data sets on the other. And the IQR is 3 hours. All right. The value 26 hours is an outlier that should not have been included in this data. Yeah. So if your IQR is 3, and I multiply it by 1.4, or excuse me, 1.5, that's 4.5. So you'd have to do a little bit of magic here on your median. Your median is at 4. You'd have to find your Q3 and add it, but this is clearly an outlier. I don't think there's any question, especially since they told you it's an outlier. When the outlier is removed, the data set, what happens to the mean? Well, the mean goes from 5 hours down to 3.5 hours. Right? You're going to add a 2. You're going to add a couple of 1s, a couple of 2s, 3 3s, 3 4s, a couple of 5s, and a couple of 6s, and you add those up, you get 49 divided by 14, you get 3.5 hours. What's the standard deviation? We can go and put that into our calculators or into Google Sheets. We can find that. And it went from standard deviation of 5.82 down to 1.59, which is a massive, massive shift. What happens to the median? Well, the median went from 4 hours down to 3.5, and you can go ahead and count that out. The IQR then, in interquartile range, it would still stay at 3 hours when you did the work there. Right. Number 6, baseball coach. Baseball coach purchases bananas for the players and the team. The table shows the total price in P dollars for n bananas. So when they bought 7 bananas, the total price is $4.13. When they bought 8, it was $4.72. 9 is $5.31. 10 is $5.90. Okay. Which equation could represent the total price in dollars for n bananas? Okay. So we have to figure out what the relationship is between here. How do I go from 7? What do I have to do to 7 to get it to go to 4.13? Okay, so 7 is what? The number of bananas. And this is in dollars. Okay? So what I have to do is I got to figure out, okay, there's something here, we'll call it X. I don't know what it is, but I got to figure out what X is. So since N is bananas, the number of bananas, and that's dollars, if you divide both sides by 7, all right, what's this X going to turn out to be? Well, the units are dollars per banana. All right, so we have numbers of bananas in the total price, so it's dollars per banana. All right, well, what's 4.13 divided by 7? Well, it comes out to be 0.059. And if you come here and you do the math, you get the same thing. You come to here, you get the same thing. You go to here, you get the same thing. I mean, look at this. 5.90 divided by 10. That's easily 5. You can do that math in your head. 0.59. So that's how much a banana costs, just under 60 cents. So here's your P. All right, I used an X. They used a P. And an N for the number of bananas. All right. And so that's the one that fits. The rest of these they just look screwed up. So I mean, if you want to look at them, that's fine, but I'll just stick with A. A is a good answer. That's what I'm looking for. Curran is collecting dimes and quarters in a jar. He's collected $10 so far and has dimes and quarters. The relationship between the numbers of dimes and quarters and the amount of money is represented by the equation. My, that looks familiar. So 0.01 dimes plus 20.25 quarters, so that's the cents, the dollar amount of a quarter, the dollar amount of a dime, equals $10. Select all the values, DQ, that will solve this equation. Okay, so remember it's dimes, quarters, dimes, quarters. So if I have 100 dimes, all right, 100 dimes, 0 quarters. So this goes to 0, and 0.1 times 100, yep, that equals 10, so that one definitely works. 20 and 50. Well, if I put a 20 in here, then that becomes a 2. And I put 50 in here, what's 1/4 of that? So that's 12.5. That's 14.5. So, no, that doesn't work. How about 50 and 20? Well, 50 times 0.1, that's a 5. And 20 times 0.25, well, that's a 5. So, yeah, that equals a 10. So, yes, that's a good answer. 0 and 100. So 0 dimes, so 0 money there. And 0.25 times 100, well, that turns out to be 25 bucks. So, no, that's not the $10. All right. And then 10 and 36. So 10 times 0.1, that's $1. And 36 quarters, well, how many quarters do you need to make $1? Well, you need 4. How many times is 4 going to 36? Well, it goes in there 9 times. And of course, 1 plus 9 is 10. So, Alpha, Charlie, Echo, your correct answers. Number 8. I'll give it a chance to focus here. Here is a graph of the equation 3x minus 2y is equal to 12. Select all the coordinate pairs that represent a solution. Oh, okay. So we just go through and just see if it's on the line. Let's see, 2, -3. So 2, -3. Yes, that's a solution. 4, 0. 4, 0. Okay, there it is. That's a solution. 5, -1. 5, -1. It's right there. And no, it's not on the line. 0, -6. So 0, -6. There it is. That's a solution. And 2, 3. 2, 3. It's up here. And no, that's not an answer. So your only answers here are Alpha, Bravo, and Delta. Moving on to the next one. Number 9. Jada brought some sugar and strawberries to make strawberry jam. Sugar cost $1.80 a pound and strawberries cost $2.50 a pound. Jada spent a total of $19.40. So here is your equation, 1.8, and that's dollars per pound times the number of pounds of strawberries that she had. All right, so X is sugar. That's your sugar right there. And $2.50 per pound times Y, which is pounds of strawberries. So that's your Y. Notice that I'm labeling my axes like I'm supposed to. Which point in the coordinates would represent the pounds of sugar and strawberries that Jada used to make jam? Okay, so I have an A, B, C, D. I'm pretty sure it's B. Point B, point B. Everything else is screwed up. It's not on the line. See, if you graph this, you have an infinite number of solutions to choose from. That's just one of the many that you could have chosen from. Okay, that looks pretty close right there. But as you see, you can go through and you can pick out many solutions, but B is the only correct one. And that is it for your practice problems on Lesson 6. So thank you for your attention.